After completing this lecture, you can describe what a neural network is as the mainstream model that is used in today's AI product. On the left side of this slide, you see a neural network in the brain, which is the computational block to process information. On the right side, there is an artificial neural network that is used to process data in artificial intelligence. There are similarities between these two units and, of course, differences. The artificial neural network in this slide is very basic. It takes 4 numbers as an input and returns 2 outputs as output. The artificial neural network consists of processing nodes that contain the weights and biases for multiplication and addition operations. W is the weight of the node and B is referred to as the bias term. W is multiplied by the information that is denoted as X on the node. The links between the nodes specify which nodes are passing the information to the next layer. In this example, all the nodes in each layer are connected to all other nodes in the other layers. And therefore, this network is a fully connected network. Note that each node has its own weight and bias term. During the training process, the parameters of the neural network is adjusted by an optimization process that feeds the data to the best outcome through the cost function. The first layer of the neural network from the left is referred to as the input layer. In this case, the input layer takes 4 values in the form of a vector. In our example, this is an arbitrary vector of length 4 with binary values. In reality, the input layer can be larger, up to thousands of non-binary values. In our 3-layer neural network, the hidden layer in the second layer that transforms the input vector to a hidden representation with 3 values after applying the parameters to the input data. In reality, the neural networks in the state-of-the-art AI models are in order of 100 layers and more. Therefore, the last hidden representations are very rich in terms of accumulation of many layers of computation on the input data. Note that the hidden layer representation is a processed version of input data and often has a lower dimension than the input vector. Last but not least, we have the output layer, which delivers the final results. This could be the classification layer that outputs the class for the given input. In the binary classification task, the output for the class output where the input is assigned to 1, and the other class is outputted as 0. To summarize, the input data of length 4 is given to this simple neural network that is processed to perform the binary classification task that assigns the input data to one category. In the training process, the parameters of the neural network is adjusted so that the network can do the best processing when deployed for the classification task. This simple neural network is also called multi-layer perceptron, and it is too simple for what is commonly used in the machine learning process of AI products. A more complex neural network is depicted here in this image, where the input layer is larger and there are 5 hidden layers between the input and the classification layer. In modern AI, these neural networks are referred to as deep neural networks. The network is deeper when there are more hidden layers. Note that this is only one example of the neural network architecture, and there are many variations of artificial neural networks in various AI tasks. I would like to conclude with a quote from George Box. All models are wrong, some are useful. This acknowledges the oversimplification of real intelligence and brain structure in AI models. Despite this, the performance of current AI products demonstrates their usefulness, even though they are extreme approximation of our real world into digits and our brain into artificial neural networks.